So with this little diagram, I'm going to be explaining what an insulator is. So from left to right, we've got our gene A, our insulator element, our cis-regulatory sequence, gene B, insulator element, barrier sequence, and heterochromatin. And essentially, the point of an insulator is to regulate the cis-regulatory sequence by using these two insulator elements. So the point of having an insulator is to kind of segregate the cis-regulatory sequence and prevent it from running amok. In the case of this diagram, we want our cis-regulatory sequence to activate gene B when the body needs it, but we don't want it to go and activate gene A otherwise when the body doesn't need it. Now this is where our insulator elements come into play. They will essentially kind of squeeze in the sequence of genome and sort of block it off from being able to be used, as we can see in the diagram below. And down here we can see that we still have all of the same elements that we were seeing before in the diagram on top. And we still have our things like our insulating elements. But now that we can see that they are sort of bound to this little middle protein, and what that protein is known as is it's the insulator binding protein. And what we can see here is that essentially the insulator binding protein has segregated gene B from gene A and segregated gene B with the cis-regulatory sequence. And just one last little bit of information is that one common example of an insulator binding protein is known as the Drosophila insulator binding protein, found in Drosophila, which is a common fruit fly.